Good afternoon, everyone. I'm Carissa Nuobei from Beijing Normal University, Hong Kong Baptist University, United International College. Today, my topic is language learning chatbot with XAI using ontology and transfer learning. This is my content. Firstly, I will introduce the abstract and introduction. Secondly, is literature review. Continuously, I will introduce the methodology, implementation, experimental, then to get the conclusion. Part 1, abstract and introduction. Language robot has widely used in customer service and personal assistant for task-oriented, interactive chats in special domain, knowledge base for question-answer systems. All of this including automatic speech recognition, natural language understanding, dialogue management, natural language generation, and speech sizes. We design and implement 3 levels for systematically language learning. The first is pronunciation for the phonetic level. Second is topic discussion for the semantic level of spatial domain. And the level 3 is free talking, the simulation of freestyle conversation. So for the industrial, when we talk with this system, the language model will generate different tutor with different personality to give response by checking the history dialogue content in order to optimize the response. And for research, we followed explainable artificial intelligence to visualize the neural network, the language model. We visualize fine-tuned data for neural network by ontology to explain output sentence from language model. And after decades of development in cognitive science, compared with Turing test, the rule-based human-machine interaction system updated to the neural network-based for generation or information retrieval-based systems. This is traditional sequence-to-sequence model of recurrent neural network, and this is information retrieval history. In our project, we use transfer learning, so this is the architecture of transformer. And initially, transfer learning is also designed for machine translation, such as BERT. However, OpenAI GPT-2 makes use of the decoder to generate text. This is our architecture. The top layer is application layer with 3 language learning levels in WeChat mini programmer. And the central part is fundamental technology, the interchange of voice to text. And the center is language model, the pre-trained GPT-2 model with 200 fine-tuned data. And the lower part is research area. We combine the transfer learning and ontology graph, following the expandable artificial intelligence. Part 2, literature review. Chatbot has divided into retrieval-based and generate-based, but XAI from Microsoft has both candidate generator and candidate ranker. So rule-based matching with real-world conversation, deep learning model training by pilot dataset, and query to knowledge graph to get related entities. For the optimized response, they use semantic computation in natural language processing and empathy matching of XAI's personality. This is the performance comparison of sequence-to-sequence model and XAI's. XAI has longer and meaningful with IQ and EQ. As our language model, we use transfer from Thomas Wolfe and his partner in 2019. They applied GPT-2 into dialogue generation to develop the conversational model. And for the expandable artificial intelligence, in our research, we follow in the paper as instruction. Our system preferred to the model explanation of local explanation with sample data during chat. That is also the connectionism research. And for the explainable artificial intelligence is for human perception. So they have 5 key points. The first is transparency, focus on the readable format for human. Second is causality. For the data-driven model, provide both accurate inference, also the background of the decision. The third is bias. Black box cannot calculate the bias of model due to the complicated computation. And the fourth is fairness. Does it avoid the unfairness for human preference phenomenon? And the last is safety. That do research confident to the output without doubt. As we all know, higher accuracy performance of model corresponding to the lower explanation. And for the small natural language processing tasks to build an ontology, we analyze the linguistic in these areas to build the ontology graph. Part 3 is methodology. For the theory, the same as neural network, we apply the connectionism in XAI with ontology at the background of bionics. This is a simulation of neural network in human brain. And for the technical, we use SPICY for natural language processing tasks, the data pre-processing of training data, then integrate the trained model based on GPT-2 with dialogue fine-tuned. The center is the system application layer platform at WeChat mini programmer. And for the explanation, we use ontology graph SPO tripper, which is extracted by SPICY and manually addition. The last is visualization of ontology graph on Neo4j graph database. This is our basic transfer learning model GPT-2. And for the implementation and experimental, how to use a generate model to complete a dialogue. For the fine-tuned part, use dialogue dataset to train the model. It not only uses words as input strings for the model, but also builds the 3 parallel input sequence for word, position, and segments. This is sample dataset of high-quality multi-turn dialogue dataset. It's natural language as input to the language model. And this is our developed tool in WeChat mini programmer. It already provides advanced features to users such as e-commerce, task management, and there is no need to install other applications on your phone. WeChat is enough. This is our designed user interface for the 3 levels. And for the first level pronunciation, the rules is more than 9 is iteration for the next sentence, and scoring is compiled the text and recording transform the text by sequence matcher on Python. Level 2 is topic discussion. We try to design and limit the discussion with 1 topic in level 2. However, our level 2 and level 3 use the same language model. So I will show the performance later. The level 3 is freestyle conversation implementation. The general process is record the user voice and store it in a local temporary file, then upload the file to service, convert to text. The text is import to language model. After we get the response from language model, it will display at the chat room. This is implementation of ontology. They consist of several natural language processing tasks. This is the example of pipeline to deal with data by SPICY on Python, such as conference resolution, tokenizer, speech tagging, name entity recognition, dependency passing tree. After that, we extract 17 relationship types linked into different two entities. And also we add some manual parts because it cannot be recognized by the SPICY. So after that, we extend to 30 relationship type linked to different two entities. For the experimental result, for the level 1, the passing rule is score more than 9. So following the first level with 5 sentence sample as demonstration with slow and clear pronunciation to make sure the voice recognition server can recognize two text. That is easier to part. And for the level 2 and level 3, we use same language model for response. So every chatting room has different tutor with own personality, such as in this picture. The tutor name is Joy and the age is 14. He is retired but enjoy fishing. And for the level 2 topic discussion on movies, the dialogue contents exist the restriction of topics. It's from movie to the music. And for the level 3 freestyle conversation, the first 3 fingers are generally speaking about hobbies in music and reading. When we talk about work, the contents from general to special domain about animals, we can extract some keywords such as animal shelter, house, dogs, and cats, also the animals. So the response depends on the fine-tuned dataset. The pre-trained only make effort and the process for agent to learn basic grammar in syntactic and semantic. This is our ontology graph. We find the most similar paragraph with dialogue contents of the response by special words, animal shelter, and use TF-IDF to construct an ontology graph. This is our comparison of system-generated and the SPO tripper. The system generation is random. However, the content is truly from training data, so we can use ontology connection of entities to explain the generated sentence. Now we can get to the conclusion. In this project, we implement the transfer learning-based artificial intelligence chatbot and using explainable artificial intelligence method to explain the output sentence by ontology graph. And in practical, language learning system with 3 levels can be applied into English spoken training. And for research, the content of output sentence can be explained and visualized into the ontology graph with the same training dataset. Also, the larger ontology graph contains more training data, the better and detailed explainable of output sentence. So in the future, we will use better surveys and optimize the functions user interface and substitute the dialogue dataset to more meaningful datasets. Also, the ontology will refresh simultaneously with the chatting rooms. This is our reference. Now I will show the demonstration of how to use our chatbot. That's all for my presentation. Thank you.